Awesome. Hello, everybody. Let me know in chat if you can hear me. I think I set everything up right, but I'm not sure. It's been a minute. Hear me? Cool. Awesome. So, let me go ping the Discord, and then we'll wait a minute or two for people to trickle in here. I suppose I should do the link too, shouldn't I? Copy. Cool, good to see your guys' names on there. I just messaged the Discord, and then... Oh yeah, I usually cast my keystrokes, don't I? I'll do that. Move that up here. Okay, there we go. Hey there, Robin Sababugs. Welcome back, thank you. Yeah, so I said this in the Discord, but this week is fairly normal, so I'm getting back to my, well, not, it's sort of a new schedule, but I'm going to be streaming this week, and then the following 2 weeks I'm going to be out of town. But then after that, it should be fairly regular streams again. I've been missing these. I keep like thinking about lovely things while I'm doing other things. So, how long has it been? Yes, the lovely return, exactly. You recently watched Banshee, and I remind you of the young mayor from the first season of the show. I haven't seen that, so. How long has it been though? I'm checking. Last stream was May 27th, so a month and 3 days ago. About a month. Sounds about right. Cool. Yeah, so part of this will be like me remembering where we left off and stuff, but should be good. Last stream was the one where we actually got executables running on the Linux VM, which I hope I still have. I think I like literally had it sitting on my desktop. Okay, we can go hunting for that later. I don't know where that is. Oh, there it is right there. Check it out. Okay, so that's still intact. Yeah, so where were we? Because we had done, we made an IR, and then we were code genning from that IR into assembly. And I'm pretty sure we hadn't done everything, but we had some stuff running and working, right? Hey, Empathy. Oh, you have a PR that updates to do that TXT? Oh man, we should go check that first, maybe. Browser will be up here. What is this? Lovely. Pull requests. This one. Test.asm. Wait, what's all? Oh, this looks like the master branch got updated, like, under your feet. Yeah, let me make a new window here. Is this the change you made? Just the one in to do. Yeah, okay, so deal with shadowing is what you did. Oh, we do have these files. I guess I should just check these. So, we did deal with shadowing. Cool. It's probably because somebody, probably me, I probably pushed to master, and then you just would have to rebase and then resubmit the PR, and then your change would be right. I'm assuming that's what happened. Because this has been open for a little while, hasn't it? May 26th. That would have been the day before the last stream. So it's just probably changes from the stream before that. Or after that. Yeah, yeah. Okay, that makes sense. So then I'll merge that. But I just made the change. I'll just close this. But thank you. Wait, no. How do I close this thing? Merge. Oh, right here. Close. Shoink. Okay. Cool. And then next up, parse function types and then finish. This is old. Yeah, that's out of date. And then agenda. There's nothing in the agenda. Discussion. Okay. All right. So let me just poke around in the code. So there's probably to-dos in here. To-do. And yeah, there's a bunch of to-dos in Codegen here. Yes, handle function types. Yep, and then what are we not doing in there? Type kind name. Oh, okay, yeah. All right, yeah. So I think it'd be these to-dos. We're not dealing with units or bools. And then some operators, conditionals, function arguments. Okay, yeah. Function arguments, I'm pretty sure was a big thing that we had kind of looming ahead of us, wasn't it? What was, let me make a new, what in the world was that command I used to run, that arch, this thing? Yeah. Is this right? Here we go. Welcome to Arch Linux. Cool. Is this where it is? Yeah. It was in here that I was doing, right? Yeah. And if I did test, it was 12 because that's what we expected from this, I'm assuming. 4 plus 5 plus 3, yeah, it's 12. Cool. So this was like running, compiling and running, which is great. And then, yes. So this is without any function arguments. Okay. Yeah, so I guess Codegen is like where we're at, and we'll just keep chugging along. I actually got a real water bottle, so I don't have to go refill my water bottle so many times. Okay. So where are these to-dos? To-do. Units, okay, bools, and then not. What's the not? Just like negating something, I guess. Okay. And then, or negating booleans. Conditionals. Yes, okay, we have to deal with those, but I don't think we have any of those yet. And then this was the biggie, function arguments. So, yeah. Also, by the way, I've been looking into the last few days. I said something about this on the Discord, but I was looking into let me get my personal text messages out of the stream. I was looking into not this. Where's my browser? Rock, the programming language. I listened to a podcast about it, and there's some really really cool ideas in here that I sort of want to steal. So maybe some stuff to discuss later on, but for now we'll stick to what we do have, just getting that to work. Okay, so a bunch of how to jump back into this. Let me make what's in here? Test.lovely. So let me make something with, well, let me just, this should work for sure, right? So we'll, yeah. Joppy says you love rock. Awesome. Empathy, rock borrows heavily from Elm. Yeah, to 100%. It's very much inspired by Elm. Hey Rex, thank you. Joppy, have you actually used rock? Okay, so this should for sure work. So let's try to compile this. How do we even do this? You tried it a little bit? Okay, cool. Yeah, I want to try it for sure. But in the podcast was like recorded a few weeks ago, and so it's recent. And he was saying, Richard Feldman was saying that they're rewriting the compiler right now in Zig. And after the rewrite is like bringing some new features and like syntax changes and stuff like that. Like this whole static dispatch thing that's new. And so he was saying that they're going to try to have it usable by Advent of Code 2025 with a new compiler. So I was just going to wait until then to actually try it out so that I'm using, what the current syntax and semantics are, instead of jumping in with the old compiler and then having to relearn some things. So, by the way, you need some way to get the same register in different sizes and register extension. What do you mean by that? Same register in different sizes? You mean like the 64-bit, 32-bit, and so on? Like parts of the same register, you mean? Okay, so yeah, RX, EX, AXIL. Truth. Because right now I just have this flat enum of registers. That's a good point. Very good point. Because I won't need... Yeah, that's a really good point. So maybe I won't worry about it yet because we're still just dealing with 64-bit integers. But once we do have to worry about it, it would make sense to have something like some data type that held onto like a register and like a part that was either like a the 64 bits or 32, or I know this isn't right syntax, but like this kind of thing is what you're saying, something like that. That would probably work, wouldn't it? it's like RAX, EAX, AX, AL. Okay. So, what was I saying? I was cargo, what does it run? No. Yeah, cargo run. This. Shoink. That compile. Looks like we're printing out a bunch of stuff for some reason. That made that, which was already there. Cool. So then, what does it do if I now... Yeah, so let's make like an add function. So if we say add is a fun that takes an x, which is an int, and a y, 2y is an int, and that just returns x plus y, like that. Get rid of that, and then over here we'll say like add. Well, that's fine. X is 3 plus, or not that, we're gonna use our function, right? Add 3, 2, 4. Like that, and then let's do x here, or I guess x minus 2. So this should go as 5, right? We got 7 here, minus 2 is 5. Try that. Okay. Failed to what? Type mismatch? Oh, because this needs to return it. Lord Pyjo, hello, where are we now? Also kind of miss you. I miss you guys too. We are kind of trying to figure out where we left off, but I think we're about to start dealing with function arguments for Codegen, because we had functions were codegenning correctly, we were running stuff, but not functions with arguments. So we need to figure out a way to pass those along, figure out some sort of calling convention, and yeah. So let's try that. Joink. Okay, that compiles. With a to-do function argument. So that just spits out in the assembly. What is it even doing? Makes our start. So then RBX becomes fun0, which is the add. Okay, and then main becomes RCX. So let me jump to fun2. Yeah, okay, cool. So then basically here we're calling our function here RBX, our function pointer, which is an RBX. We're not passing along any arguments. We're moving the return value into R8. Okay. Okay. So yeah, how are we gonna deal with function arguments? Like, what would we want this to look like? Well, like, where is this even trying to read function arguments out of? Where is add? Add is fun0. Like, where did these come from? RSI and RDI? Did we decide on some sort of calling convention? Yeah, is that what we decided? RDX. Wait. Oh. The biggest problem is that all things are stored in registers, so there's no place to store extra variables and function parameters, and registers need to be safe for calls. Correct. All right, so maybe we should think about this a little bit. These are our registers. And we were not using these two because we use them for the stack, and then not using this one because that's where like return values were going. And then I had some concept of a register stack. Wow, okay. It's hard jumping back into a project like this after a month. Shift stack index right. Should probably use the stack frame for storing things. Is it just like the stack? Check the enter instruction. What's the enter instruction? X86. That's enter. Enter creates. Enter creates a stack frame, and leave destroys a stack frame. 0, 0 parameters on enter, they're basically equivalent to this. Wait, what? Move, push, EV. First parameter enter specifies an amount of space to allocate for local variables. Yeah, if you want to post example uses in the Discord, that'd be fantastic. We have that stream chat, don't we? Yeah. Okay, so conceptually, what is it I want to do here? Because this is turning my brain into mush. Well, we've got really good error messages here. Okay. Like, where is discussion? This is what this is for. Whoa. Function calls. So, oh, here we go. Something like this. Like this. Stirs offset 8 from RBP. Yeah. Enter. Conceptually, what is enter actually doing? It's like making a space on the stack. Is that correct? Right? Enter 5, 0 is like pushing that, then moving the stack pointer into that value. and then moving the stack pointer by 5. So it does seem like that's what it would be doing. Creates a stack frame that sets up RBP to a useful value while also saving the old RBP and allocating stack memory. In this case, 8 bytes. Okay. That makes sense. So then, how are we going to use that? For the string pointer. Gotcha, yeah. So right now we're storing all temporary values in here. Oh man, this is hard. In registers, right? And we want zeros add. So then we could have each variable have an offset on the stack. Like that is attached to that variable's data structure in Rust. You can save locals and parameters there and use registers for faster access. Then what would I use registers for, if not for yeah, if I'm putting everything like that on a stack, then what do I end up using registers for? Just like optimizations? Is that what that kind of becomes? So everything that I'm currently putting into register, should I just put those on the stack? Does that seem reasonable? Variables can be pointed to, and those ones would have to be on the stack for that. But every other variable can be stored in a register, I think. Well, the thing, like there's a finite number of registers, but there's, I mean, the stack obviously is finite too, but like much bigger. So what if I have more than however many, like 15 variables, right? I can't store them all in the... So you think register is just for optimizing? Bro creating programming language. Bro trying. But, well, let's see. Okay, so registers are going to be just for optimizations, and everything by default is going to go on the stack until we find, like, you know, bottlenecks and slow spots. Then we'll bump stuff into registers and be smart about it. But until then, we're going to be dumb about it, or not dumb, but no premature optimizations. So then basically all this code is garbage, which is cool. Why is my desk so low? Okay, I'm going to, yeah, so this kind of needs refactored. I almost wonder, because I had made like my own stack system that just used the registers, which is basically not needed anymore if we're going to be sticking everything on the stack. And it's really... What would you name this? The language is called Lovely. You can still use the old system, just swap the variables between the registers and the stack. and save them on the stack for function calls. Just swap the variables between the registers in the stack? Wait, what do you mean by that? Well, I don't have a concept of a stack yet. Here, like there's not a single like push or anything. Or there is. What's this? Oh yeah, that was just for mall and stuff. Okay. Lovely. Yep, that's the name. So only put them on the stack when using more than 16 variables or calling a function. Oh, so you're saying I can still use the registers. Oh. Okay, so you're saying, correct me if I'm wrong, you're saying basically extend, like I have this stack system, keep the stack system, but then it's like extend it with now like stack place 0, stack place 1. Is this what you're saying? So you just treat like the stack as an extension of the registers, or better said, treat the registers as like a prelude to the stack. Is that kind of what you're saying? Because that does make sense, and I think that is what we were initially planning on doing. Know that every value in a register also has a stack place for it, and put it back only when you need to put it back. Every value in a register also has a stack place for it. Oh. That makes sense. Okay, so then more like if these are the registers, then the stack would go like next to it down, right? And then these right here would correspond each register place to the first, 15 or 16 stack spots, but then the stack keeps going, and you can store those first 15, which is like the top of the stack, which is what's used the most often, in registers as an optimization, but then overflow down into the stack if it gets too much. Is that right? You'll write a quick example. Yeah, that might be helpful. I think I get what you're saying, but I'm not 100% sure. Discussion. So if these are registers, it's like R0, R1, R2, R3, and then the stack starts here, S0, S1, S2, S3, S4, S5. This is sort of what I feel like you're saying, but correct me if I'm wrong. Like these correspond. How can I show correspondence? Like that. And then when you get once you get to here, then you need to continue down over here. It would be simpler though just to use the stack, wouldn't it? Because then, okay, what about function calls then? Because won't you want to use registers for calling convention? Probably. So what if I just kept everything on the stack? And then use registers for like calling convention and optimization and stuff. This is beyond me. Oh dear. Would you rather make it work with your old system or write a new system? I don't mind writing a new system. This was only like, well, a lot of this is repetitive, right? And it's only 275 lines. I'd rather just do whatever makes the most sense and not take into account like the pain of writing a new system, because I don't mind that at all. Okay, here we got something from example function. Okay, you're just returning, it's just add. Enter OX. First quad word. First register. Okay, so here you're making like aliases, right? You're just calling 24 here. Wait, isn't that incorrect? Wouldn't it be like 1 8 if it's hex? Because you're trying to do 3 8, right? Is that right? Joppy says he gets it. Okay, first, so these are just aliases for those. Okay, which are just spaces. They're all the same thing though? That's what I don't totally understand. Like, why are these all the same? Okay, and then the parameters come in through whatever the calling convention is. Say it's RDI and RSI. That makes sense to me. Okay, here's corrections. So this, just 24, not OX 24. These, this looks like some language, I don't know. This is a 16. This is probably a 24. Oh, it's a 24. Okay, I get it. Yeah, 8, 16, 24. Got it. Yes, okay, that makes a lot, this makes a lot more sense. So these are different, and then this is just 24. Perfect. And then parameters, this makes sense. Okay, so the parameters come in through RDI and RSI, which could be anything, but say we choose that for the calling convention. You move those into there and there, which are now different places. Quad word size. And then move first register from register. Yeah, yes. The first one into there, the second one into there. And then do the third. Okay, and then you add them together. And then you move the result. Ooh, this makes much sense. I get it. I get it. I like this. I like this. This totally makes sense. And then you just have to make sure to leave and ret. Because leave will reset whatever you did up here. Is that right? And then ret will jump you back to the call site. Green is 1624. Thanks. Hey, cat cement. Okay, so this totally makes sense. Is my understanding of that somewhat correct, I hope? And then the question, I guess, still just holds, because you said, like, register stack. Should we do this system for the register stack? Like, start with registers and then overflow into these, just skipping the registers that are going to be used for calling convention and stuff? That, or just this system, or this system? Oops. Which one is better? Each register corresponds to a space on the stack, and we use the registers in the function body instead of the actual stack spaces. I don't understand the whole correspondence thing. Like, this is the correspondence I'm assuming you're talking about. How does, in practice, what does that actually look like? Like, is the values actually stored here, or is the value actually stored here? And then wouldn't that mean, like, copying it back and forth and wasting CPU cycles? Yeah, I'm just a smidge confused about this. Like, what's wrong with this system? Doesn't this seem like cleaner? Negative optimization? Yeah, I feel like it would be like that. I'm not sure though. Some person, do you have any problem with this? Like, what's... I feel like this is good. I'm not sure if you are allowed to use a memory location as a math input. So you get it off the stack, then do something, and then return it to the stack. That's a good point. Yeah, I guess that's how it would have to work if we did it this way. Whereas this way, so in this way, would they always be stored here, and then only if you needed to use these registers for something else, then you temporarily move it onto its stack value and then use this register for the other thing and then move it back onto its stack value? What to study to build your own programming language? I'm in 11th. Doing it, I would say. I don't really know how, and I'm just giving it a shot. So I'm not really the best person to ask because I've never succeeded before. But I've been learning a ton just by trying it out myself. So, okay. The problem with extending the register stack with the stack is that all registers need to be cleared anyway on function calls, and the amount of stack memory needed is unclearer, less clear. I like unclearer. Is that all registers need to be cleared anyway on function calls. Oh, and you're saying so if you cleared all this on a function call, then you lose like most of your thing. Whereas if you cleared these on a function call, you'd still have these backups. Oh. That makes sense. Is that what you're saying? So these basically function as backups to this, for function calls because these get cleared on a function call. 1 in chat if that is correct. 0 if I'm totally wrong. Have you ever worked with LLVM? I'm trying to get started with it. I have never touched LLVM. But I've heard good and negative things about it. Good is that it's absolutely phenomenal and does crazy optimizations and everybody uses it. The negative is that it's sort of tricky, I've heard, but probably not as tricky as doing everything yourself. So yeah, I don't really know much about it. In your opinion, it's simply just to use the stack and not even do either of these? Oh yeah, I forgot about that option. There's this option too. Option 1, option 2, and option 3. Three is clearly the most simpler. QBE is simpler than for a single person to understand, is it? Yeah, then LLVM, gotcha. 3 is most simple. 3 for the, okay. So 2 bad because registers need to be cleared. Right? 1 fancy, backups, somewhat complicated. And then this is like simple, easy. And then there's nothing preventing us from using dropping down to registers with this either. Simple and easy with no consequences. Well, aside from performance, yeah. That's the thing is performance. Yeah, okay. You are supposed to drop down to registers. Yeah, and so we will for optimization things, right? Because registers are supposed to be faster than stack pushing popping. All right, well let's do a vote. A poll. Which one? 1, 2, or 3? Okay, my least favorite YouTube feature is that I can't vote in my own polls. Are we worrying about optimizations right now? Good question. We're not. At least I'm not. Let's say we have 2 local variables x and y and you want to add them together. You would put both on registers and then do math and put the result in some memory stack. Yes, correct. Yes. So at the end of the day, you're going to be operating with registers, but you're just going to be pulling things out of the stack to then do those operations. Whereas in this method, more often you could skip that step of pulling them out of the stack, but it's a little bit complicated and I don't know if it's worth it for now. Jappy, I don't think Cat's solution is necessarily 2. All right, so let's do 3. We're gonna do 3. I'm choosing 3. And then if we want to get fancy later on, then we can get fancy later on. Okay, so we're gonna just stick everything on the stack, which means I sort of need to fix this system. Well, this is still valid. Like the concept of a register is good. All right, get rid of this for now. That's still good. We want to be able to display those things. Register item. Variable. Function pointer. Okay, I kind of want to just. This is all gonna be totally different, right? Well, okay, no, not this as them instruction to as them. Not necessarily. All right, I'm gonna comment this out so I can refer to it, but I'm gonna try to write this again from scratch. Where are global constants stored again? Thanks so much, Kat. Thanks for stopping by for a little bit, and hope to see you around Discord and next streams. In registers currently? Well, currently, yes. Yeah, could we just stick them on the stack like with the other things? Is there a problem with that? Or it's not good? Oh. Well, where should we stick global whatchamacallums? Variables, constants. All right, so I'm gonna get rid of this. If global should be accessible in all functions, then they need to be in the data segment. Oh. Okay. And globals and lovely are just what? Just like top level. Like if I say like foo3 on the very top level, and that'd be a global, I guess. So that kind of stuff should go in the data segment. Okay, that's cool. We won't worry about that quite yet. So register is good. This makes sense. I'll keep those. This is no more. All of this I'm going to comment out, so I can refer to it, but I'm not going to use it. I don't need this. We kind of have to worry about it, do we? That's why there are restrictions on what can be global. Yeah, and we already have the restriction, right? Isn't there like an is const or something? Yeah, this guy. I'm pretty sure one of you guys made this. Or maybe I made this. One of you guys suggested it. I forget who made it. Yeah. But not like, because you can have global constant functions in that. All right, well, anyway. So I'm going to have my own new pub struct Codegen. This is going to break everything. Just a thought, you should name your format tool Lovelier if you decide to make one. There's definitely going to be one, and Lovelier is a very good name. Because it's like prettier but lovelier. I think I might go with that. Hold on. Tool names.md. Language is lovely. Formatter, lovelier. Testing framework is called Lovebug. I decided on that a little while ago. Yeah. Okay. I'm open to any other suggestions. We need a name for our LSP and other things, but until then, we've got those. All right, Codegen. So we need some sort of stack. Loveify. Yeah, Loveify could be good. How to make a stack? Do I make some sort of pub I still have not done much toward a formatter, but I had the idea of saving the spans of everything and inserting the comments that way. Wait, how would that work with comments? Saving the spans. You mean like looking back at the source code and like pulling the comments out and then inserting them in the formatted code? Is that kind of what you mean? Like as opposed to parsing them and having them be part of the AST? Oh, I can probably end this poll, can't I? Yes. Okay, that makes sense. Yeah, that'd be great. Whatever you think. I don't. Yeah, do whatever you think is best. The one thing I will say about the formatter, I'd like to keep it like very unconfigurable. I was listening to that podcast about Rock, and Richard was talking about how Rock has a 0 configuration formatter and how that's a feature. And I kind of like that mentality. If we want to do like one thing for like tabs versus spaces or something, that's fine. Maybe, I don't know. But for now, I think at least let's try to keep it not very, like just very opinionated and not configurable so that people don't argue. All right, so the Codegen, what is this even going to hold on to? I don't know. Impl Codegen. We decided 3 spaces. Oh yeah. I'm not sure if that was the best decision we've ever made. Isn't that like slightly ridiculous? Personally, 3 spaces. I mean, maybe that's fine. Oh well. Yeah. That'll be just one number, hopefully, to fix over in the formatter when we're done. Right in between 2 and 4, a win-win. Yeah, everybody's happy. Or everybody's unhappy, depending on how you look at it. Alright, so we'll have some sort of new here, pub, fun, new, returns self, and it just does this because self doesn't actually have anything yet. And then at the end of the day, what does this thing need to do? It needs to take, so we get some sort of our tech, right? This guy, mod. IR generator, what's this IR generator? Impl new, add var, look at var, get ID, add block, add instruction, program IR. Okay, so it takes a vec of basic blocks and needs to return a something, a string really, because at this point we're just generating code. Also, yeah, it's probably not worth it at this point to like worry about different architectures and optimizing this for the future when we expand to other architectures. You're just gonna say Codegen, it's just gonna make NASM. So, but in the future, I'd love it if it could work on other architectures. Yada yada yada. Like, what do you do? Oh, get temperature. Entity as an entity. Wait, it's a vec of basic blocks. Okay. Like this. Here we go. Gen asm takes a slice of basic blocks and returns a string. That's basically what we need. I'll steal that from myself. So let's stick it here. Gen asm. It'll return a to do. This needs to be imported. Cool. So then, yeah, just a matter of looping through these things. Basic block. What is in a basic block? A basic block has a label and instructions. What does it? So like this is what we're getting. Entry. So entry becomes like the global start shenanigans, right? Do I have some check for that in here? Oh yeah, so entry maps to start, otherwise it just keeps it. Yeah, that'll do the trick. Okay, so I'll make a function that's like basic block to asm. Looks like I already had that down below, which takes a mutt self. Block is a basic block. It returns a string. Okay. So then we'll just maybe this should be a ref probably. Also, you need to know how many variables you're going to use in a function to allocate enough stack memory. Truth. Yes, okay. We'll think about that when we get there in a second. Hold on, I'm gonna switch out for my yoga ball. Okay. Now I'm bouncy. So then a basic block has a label. What is a label? Oh, it's just a string. That's nice. And then some instructions. Instructions are one of these things. Yeah. Okay, that's pretty easy. So then this guy will just say like for basic or for block in IR. Block is now ref to a basic block. We're going to say let my blocks equal vec. Oops. That'll be resolved shortly, and then I'll say blocks.push basic block to asm block, no, and then I'll return blocks. Probably something like that. That's pretty basic. Should work for now. And then for my next trick, I'm going to spit out okay. Now, like what happens if I now run this? So it actually works. So now we're taking this add thing and we get block, block, block. Perfect. Is it frozen? It probably is frozen. Is it the daily freeze? It is the daily freeze. Welcome to this episode of the Daily Freeze. Hold your horses, folks. How do I fix this again? It's been a little while since I've done a streaming. Wait, how do I do this? This. Wait, I think I just get rid of those. Joink. And then add video capture device. Okay. Device. This device. Perfect. Okay, now you see me. And then screen capture. Okay. Not this screen. But this screen. Joink. Joink. And joink. Okay, make this be the full size, stretch it out. And then, so, okay, now that's not frozen, and then I can stick this guy down here. Ta-da, wrong side, over here. Hope you enjoyed this week's episode of the Daily Freeze. You could also do that. Where would I do that? Oh, like here? Yes, it is a streamly freeze. I usually do a stream a day, so. Well, okay, that's not fair. I haven't done one in a month. Blocks, iter, map, fold. Oh, you're saying just like do this in a one-liner? All right, challenge accepted. Blocks dot map block self dot basic b. Hold on, iter dot map. Okay, and then dot fold. And then the function here, what does it take? An initial and a closure. Wait. Fold, 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 fold. The second one, is it item and ack? Is it like this? Hold on. Okay. Ack and item. Ack and item. Item is a string. We'll find out shortly anyway. And then we'll just do ack dot concat. Wait. How do you like concatenate strings in Rust? Ack dot con format. Is that how you do it? Ha! Look at me being all functional. Please change iter to into iter. What's the difference? Wait, iter? Into iter. It's equivalent to iter and will not consume the slice. William, you're free. It doesn't matter here. Wait, what is into iter exactly? What was, okay, I got it. I was saying hi to William. Hi, William. What are we doing right now? I'm sort of rewriting the Codegen thing. We're gonna switch to just using the stack for everything because it's scalable. Yeah, good to see you back. Into iter converts, iter creates. Interesting. Iter iterates over refs and into iter over the values. Oh, so into iter like consumes everything and gives you like an iterator, and then iter just like lets you bounce over the things. So iter can never own the items, but iter. Okay, gotcha. Any old who. Let's confirm that this still works. Joink, and then sure enough, it still works, but we got one stray new line out at the top here, which is a little bit unsightly, one might say. Well, there's a trick for this. It's called trim. Shoink. Ha. There we go. All right. Now it's looking so good. Although, I kind of want more space between my blocks. This looks much better. Lovely. Okay, wait, we got more comments. But for slices, into iter iterates over the refs because it can't own the values. Gotcha. Hey, IC. Good to see you, man. Okie dokie. So then, it's a matter of doing this, which is these things have labels and instruction lists. Correct. Good job. Okay, so then labels are literally just strings. So that should be pretty straightforward. I'll say the YouTube description says lonely. Oh no. This is terrible. I will fix it right now. Hold on. Hold your horses. Fear not. Content. Live. Is this the current one? Lovely. 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 Oh, lonely. Lovely. Thank you kindly. Great. Should be fixed now. Hey, come back here. So you stay up there. Bro, I want to do this someday. Yeah, you should start. Try it out. It says both lovely and lonely. You can't decide. Well, it's confusing when you switch back and forth a couple times. What is going on, chat? I'm rewriting the Codegen because we realized that keeping everything in registers doesn't exactly scale. So I'm now sticking stuff on the stack. And rather than try to like adapt all this complicated stuff, I'm just trying to rewrite it. Okay, what is next? Oh yeah, okay. So I'm gonna say like I don't know, let my lines equal oh dear. And then I'm gonna say lines.push format. What are we formatting? Oops. Basically block.label, which is just a string. And now I get labels. And then the loveliest language is written in the rustiest. For now. Until we self-host. And then the loveliest language will be written in the loveliest language. Alright, and then for inster in block.instructions, we will lines dot join. Oops. Okay, so we got all these insters, which are refs to instructions. Perfect. We will just lines dot push. Just to test that this is working, I'll just say instruction, and these also ought to be indented. Joink. Try that out. See the output. Very nice. We have entry. Oh, entry needs to be turned into like the start thing. Hey, nice to see you too. Thank you, computer scientist. This is already starting to look good. Already starting to look like ASM. So then we did a silly here. So label, we should match this. Match. Can we match on this? I'll make it easier. And then, oops. New Vim indeed. Ooh, no. Wait. Foo? What's the matter here? Unreachable expression. Oh, because this diverges. Gotcha. You can't tell the difference between instruction and assembly. I barely can either. Ghosty 2, yes. Compiler interpreted definitely compiled because we're trying to use this. It's a low-level systems language. Goal is being running an OS, but you know, who knows? We might make the next Twitch for developers too. String implements add stir, which is way more efficient than format. Are you kidding? Like you can use the plus operator? Wait, are you trying to tell me that you can use the plus operator on strings in Rust? What kind of... Oh dear. Oh dear. Oh dear. Oh dear. Oh dear. Whoa. Oh, these can be joined, can't they? Big brain move. You know you're a 10x dev when you realize that this can be turned into this. Okay. Yes, and then and the item. That's very nice. I had no idea. I was in the dark. Okay. So that is much better than format in a lot of cases. Lovely is going to have proper string interpolation. So you won't have to use format and stuff. Okay. Where were we? Down here. Okay, so yeah, I remember. So this is like that case, but if you get something like what is it, entry? If it's entry, then replace it with start. Ta-da. Okay. And then if it's anything else, just keep it. This should work wonders for us. Sure enough, now we have start here, and then the others keep their names. Very nice. We don't need that or that. Okay. Very, very nice. How will the string interpolation work? Like syntactically, or what do you mean by that? I don't even know how strings are gonna work, but I do know that string interpolation is kind of nice in my opinion. And I feel like we can make it work. Like syntactically and semantically. Strings aren't going to work, period. Yes, good point, William. I don't know about like syntactically. Like in JavaScript, they do $squirrely. In Swift, they do \parens, like that. In Kotlin, you can just do like this, var name, like, which is interesting, just like right in there. Hi there. Like, hi, here's the options. I don't know, something like one of these. Maybe just to mix it up and be different, we'll do $parens. I feel like $parens actually looks kind of good. But yeah, we'll cross that bridge when we get there. Hello, Tara or Tara. Not sure which. Or maybe something totally different. Can you make a cool website with only HTML, CSS, and C++? You absolutely can. If it doesn't have any client-side interaction. But you can go a long way with like forms and, yeah, form actions and stuff. Yeah, but like how will the object be printed? Will there be some default printing function for every type or some protocol? Good question. Probably some protocol like display like in Rust. But we could do something different. I'm not sure. Probably like a default display protocol that gets auto made for everything that you can then redefine. I don't know. That's a little ways off, so we'll think about that later. But some good questions. Thank you, William, very much for the description of what were you doing. Those are always very helpful. All right, so where were we? We got this. It looks good. So now we kind of need to turn these instructions into things that make sense. So we'll have a, what is this type? Instruction. Perfect. So we'll have instruction to ASM, which is very similar to the other guy. Block takes a, not a block. It takes an Instagram, not an Instagram, an Insta, which is an instruction, an Instagram. So it takes an Instagram and then returns a string. Shoink. Why? Oh, I forgot self. Maybe add to the to-do list. Good idea. Smart people. To-do. Okay, I feel like this to-do list isn't very... does the readme have... No. This has like a random stuff. This is pretty random. This is pretty random. This is not being used. To do. Alright, just gonna get rid of stuff that we've done. Alright, just the stuff that we need to do. Error handling. Yeah, logical operators, shift operators, support variable declaration without initialization. Oh yeah, okay. And string interpolation. Might, we'll say no. Might want to work on strings first. Just in case a contributor decides to try to work on this before we have strings. All right, where were we? Over here. All right, we got more comments. Built-in JSON serialization would be crazy. Built-in. Like built-in SERDI, basically. How are you planning on doing multiple targets? You mean like multiple architectures? Well, good question. The thought is that I'm ignoring the problem for now, but then going forward, wouldn't I just have to kind of like abstract these three functions out into like gen asm, and then we have gen arm asm, and gen this asm, and gen that asm, and then you just kind of split off at that point. But like up until this point, it all kind of is the same, and then we just branch off here. I think. I don't know. I'm open to suggestions. If string interpolation is part of syntax, shouldn't we have the syntax part of it decided? Yes. All right, we can decide that right now. Tangent. Wait, we haven't even decided string syntax though, so I guess we mentioned strings many times, but we never like formally introduced strings. So I don't even know if we want to, because like string types are complicated. So I'm not sure if I'm ready to think about that yet. Because like just, what's that? Is there like a meme about Rust string types? Rust, where's my other browser window? Rust string types. Oh yeah, this one. We got to think through all this stuff first before we can start worrying about strings, and then we can start worrying about interpolation, I would say. Oh my golly gosh, we don't even have strings. Correct. We decided array types, but not string types. Yeah, I feel like array types are almost simpler than strings. Like strings are just kind of like a special case of array types, aren't they? But yeah, syntactically that's maybe ridiculous. Hold on, some more things. Is it good to study multiple programming languages at a time? I have done it, and I usually end up sticking with one of them. But I could see it being done and being profitable. Just know that if you're splitting your time between two things, then you're splitting your time, right? So that's kind of. I see. Supporting x86 64 for Linux and Arch 64 for Mac OS and x64 for Windows, etc. Yeah. Yeah, I'd love if we could do all that. All right, let's keep going with this. So we have our Instagrams. We're going to turn to do our Insters, turn it Instagram. So we'll say, what are we going to say? Yeah, I guess we say lines.push self.instruction to asm inster. How about that? Why don't I need a semicolon right there? Because it's the last thing in the for loop. That's weird. Okie dokie. At my school, they teach 3 languages at the same time, and I'm lost right now. Ooh, interesting. What are the languages? I'm curious what 3 they chose. Java, Python, something else, maybe? Okay. For strings, you can maybe use add assign instead of a vec of strings. Add assign. Oh, like plus equals. Is that what add assign is? Like the lines plus equals foo? That kind of thing? That actually does make a lot more sense, perhaps. Perhaps. Sure. Excuse me. And then we'll just do joink plus equals row. Oh. This needs to be that. Whoa, Guy98 took some classes with OCaml. That's awesome. I'm a big OCaml fan. String uses a vec as a buffer, so instead of a vec of vecs that need to be joined, you just have one string. Correct. Yes, that makes a lot of sense. You wrote a compiler in Java for school. Awesome. Is the fact that Java is so like instilled in schools just like a legacy thing from the past, or is there actually like a good reason? I'm a little bit unclear on that. Yes, OCaml's totally goated. Okay, and then here we say asm plus equals self dot instruction to asm inster. Ta-da! This needs to be a ref, and then we just return lines, which is actually much nicer. Although we really should be doing. Okay, hold on. This needs to get a new line. This. PHP guy, cool. Java is like the French of programming languages. What does that even mean? What is French? I mean, I know what French is, but like, why is it the French? Java's making a comeback? I thought like Kotlin kind of killed Java. Oh, you learn in school. Gotcha. Yeah. What is French? Guide 2025. Yoga balls are fantastic, but if you keep them in your bedroom, then they like roll all over the place and destroy everything. One of the most common languages people learn when people want to learn. Yeah. Gotcha. Okay. We were Instagrams to Asm. Yes. Okay. Although I should probably be consistent and okay, never mind. I don't have to be consistent. So instruction to Asm. So now we just match over because this is an enum. Yes. Okay. So we match on inster, joink, and we have all these things. Probably makes sense. Well, yeah, we just keep that. Okay. So why am I bouncing? I was bouncing because I was on a yoga ball, but now I'm standing. And JavaScript is the English of programming languages. That's funny. Yeah, Java is. I learned Java very briefly for a test. It was actually so I didn't want to take a class. Well, it was like a intro computer science class, and I figured that I could just test out of it because I'd been programming for a while. And everything on the test I knew about, but it was just the whole thing was in Java, so I just learned the Java syntax just to take the test, and then yeah, it wasn't very difficult. You really need to take into consideration how you're gonna handle multiple targets. Is my current thought not sufficient? Or because can't I just like refactor, like what if I just called this like x 86 64 asm or Linux, right? And then just have more of these for the other. I mean, that's a little bit repetitive. Perhaps we could find a cleaner way to do it. Like, doesn't it seem like that's not a super hard thing to add later on? But I could be blind to something that you're seeing. All right, anyway. Put some stuff on GitHub so you can look because it's a pain to explain in YouTube chat. Okay, that'd be awesome. Thank you. Oh, I just saw your thing in Discord, some person. Oh, one of the things, okay, one of the ideas that I really liked from Rock is that like at the type level, there's a difference between pure functions and effectual functions. So like functional people will think that's awesome, I think. But I really like that. And they have like a syntactic difference. Like they use like single arrows for pure functions and double arrows for effectual functions, I think. And that's cool. And so then you have like pure functions can't call effectual functions because then they become effectual, right? And so then there's like that distinction, which keeps things like very clean and organized, which I think is really cool. What do you guys think? Okay, here we go. Something from IC. Let me pull that up into here. close these. I don't need these. Oh dear. Is this a new project I see? Jap, you stole that for your future functional programming language? Oh, awesome. Check source Codegen. Source Codegen. We got a bunch of things here. Ooh, C++. Where? Is this a prefix plus plus? Emitters? Oh, codegen.hpp. Target. Has an architecture, an OS type, and an assembler. Valid combinations. That's interesting. And then you have these targets. Check emitters and emitters. Oh, and then you have each of these. So you started with macOS gas, I'm assuming, and then you'll just have the others later. Oh, this is super cool. Yeah, that's super cool. I still feel like that makes a ton of sense, but I still feel like that won't be a huge refactor later down the road, or maybe I'm just deceived. Like just copying some functions around. Like, is it worth worrying about right now? Const fn is basically the same thing in Rust. I haven't used that in Rust. Does that force things to be pure? Oh, const in the sense that you always get the same output with the same input, which is what a pure function is. Like the register allocator, for example. Well, I'm not really using the register allocator anymore. Like for my own homemade stack thing. Okay, fair enough. I could get behind that. All right, what do you say, guys? Do we start worrying about this right now? I tend to trust what IC says because he has some experience. Just saying, keep it in mind. Yeah. Yeah, that's good. Appreciate that. Does anyone know how you can take WASM compile JS automatically? Wait, how you can make WASM compile JS automatically? Sorry for the question out of topic. I do not understand the question, but maybe somebody else does. Make WASM compile JS automatically. Okay, well, so we could do the refactor now that might make sense since I am at a point where I have very little code. Let's do it. I like your whole emitter system. That was clean. I like that. All right, let's do it. Let's do it. Arch. So this will have all my like arches, or I guess targets, because yeah. Targets. Main. And then where's targets? Okay. And then What were the ones you had? Like platform or OS, right? OS. OS, you had an assembler, right? Which is an assembler. Architecture OS, okay, yeah. Assembler, assembler, and arc, architecture. OS types are Mac OS, Windows, Linux. How specific do you get with these things? Like what do you do exactly? Okay, you just do Mac OS and Linux. Sure. I mean, do I include things that I'm not? Yeah, it's basically a target triplet, exactly, Jappy. I think that's right. And then assembler is like NASM. What else is there? Like FASM, NASM, FASM, gas. Isn't that something? Oh well. I'll just do the ones I support for now, and then we add them as we go. Architecture is like x86 64. I don't think I can lowercase that. That's annoying. Awesome, back to lobby. Why use multiple assemblers? I don't know. I'm not sure about that. Water break. Oh dear. I just spilled it everywhere. That was way too full. I literally just dumped water all over the floor. Okay. Let me grab a towel. I'll be right back. Should probably pause the stream, no? Pause the stream. Okay, got the towel. Okay, that should suffice. I can go right there for now. Where were we? Because some assembler can't compile certain assembly syntaxes. Kaya jump scare, yeah. All right, so so I could stick a bunch more on here that I don't support yet and probably won't support for a little while, but for now, should I just stick on the ones I plan on supporting? Probably doesn't really matter. Something about this water bottle makes it very difficult to drink out of without dumping water. Okay. All right, we'll just leave these ones for now. So then, cool. Wait, how do we do this? Like supported. Can I make like a static? So aren't they supposed to be uppercase? Supported. Targets. is a vec of target. And then we'll have a target. Uh-oh. Wait, so how can I do this? That's annoying. Not be static? I can't just like... Uh-oh. You think I want an array? Oh, you mean just do this? Wait. Boom, how's that? Fancy. Static array, yeah. That's what this is, right? And then tub. Uh-oh. Tub. Got it. Okay, so then there's that, and then we'll have yeah, okay, so then I guess somehow we'll have to have, okay, so the Codegen, then over here we'll have oh, this is gonna be interesting. Okay, so yeah, you need some sort of like emitters, right? Emitters. And the only one that we're supporting, what's like the order you're supposed to write these triple, what did you do? You did architecture, OS, assembler. That makes sense. So this would be NASM. Wait, what was the Linux? No, not NASM. It'd be x86 64. x86, oops, x86 64. Linux NASM. Kai, since using Rust, I'd recommend probably using a trait for all the methods. For which methods? You mean for all of these? Down here? Then what would the trait be? Look at source, Codegen, this guy contains all the methods. This one? At the bottom. Oh yeah, these guys? All the other emitters inherit from it. Oh, gotcha. Which would be like traits in Rust. Okay. Get emitter. Gotcha. Okay, that makes a lot of sense. So then we have a trait called emitter. So I'll have something like that here. I'll have something in here that says, oops, mod emitters. That is a nice idea. And then I'll have in here trait emitter. And then oh, machine vendor operating system, Jappy. Is that what a target triple would be? Yeah, if so, then this isn't it. Yeah, this is very similar. The concept is very similar. Okay, so then emitters need to have, they basically just need to have this gen asm for now. Maybe a new. I just want them to have this for now. Oops. That's a good trait. And then, yeah. So then I'll make this guy my first emitter. Oh, I need a mod X, this guy. Struct X 86 64 Linux NASM emitter. That's kind of really gross looking. How could I name this better? Suggestions, people? That. Imple emitter for X, the guy. Just call it emitter? Ooh, that's not a bad idea. But then I have two things named emitter. Wow. Shoink. I think it'd be, yeah, I think you're right. I think it'd be better not to call this emitter trait, but rather to call this code emitter. And this becomes code emitter. Hey there, Darshan. Yes, William just gave a very good explanation. Is it a register-based VM? We are currently switching to storing variables and local things on the stack, if that answers your question. But I'm not totally sure what you mean by a register-based VM. How did I get things to look like this in Ghosty? This, like all this and like the pop-ups and all that jazz, that's Zellage. Yeah, there's no VM. Zellage, I'll put Zellage. Who asked guy 98? Zellage. There you go. That's how you spell it. It's like Tmux, but a little different. Okay, so then Genasm, yeah, okay, that's good. So now I can sort of copy over. Okay, like I don't know how much of this I'm gonna need even. Okay, get rid of these registers for now, because we're not even using those. I'm just gonna steal this whole thing. Shoink. and pop it over here. And then I'll also have this guy. Except the gen asm will just be this guy. Oops. Oh yeah. IR is a language higher level than assembly, but lower level than our actual programming language. Exactly. Yeah, Chappie gave a good explanation. On IR, it stands for intermediate representation, I think. That's which sort of explains it. Like if our language is here and eventually when we get down here to assembly, like you can go straight down, but that's kind of like a pain to wrap your head around. So you take a bunch of intermediate steps, and one of those is the IR. Really, they're all IRs technically, but the one that we're calling the IR, it looks like this. We're basically turning everything that happens into simple steps that are easily translated into assembly. It also makes it easier then to target different architectures and OSs and stuff, because then you just take this and translate it into different dialects of assembly. Oh, Guy just joined the Discord. I'm assuming that's Guy98 from chat. If so, that's great. Glad to have you. Yeah, William gave a good explanation too of IR. Okay, so then this is all looking good, and basically there's nothing left in here, which means what? I'll keep it for the sake of reference, but it's not really serving any purpose anymore. All right, so we just go through these. Oh, but we should probably, that's a good idea. Fix this. So this should be, oh dear. This should be, okay, that is pub. Code emitter, I don't like that. Let's do code generator. Code generator? I don't know. I don't know what to call it. So this, to be able to reference that, that'll have to be pub. And then this will also have to be pub. And now we should be able to pull that in here and use it. Code generator. This guy. Janasm. What? Oh, I need to import the trait, don't I? Use Codegen emitters. Right there. Cool. What happens now if I try to wait? Some to do happened. Oh yeah. It's these to dos. All these guys. Okay. So let me actually oops. Oops. You spelled generator wrong. Oh yeah. Thank you. Thank you very much. And then make these just temporarily say what they should say. Because these are going to take a little while to fill out, and I want to get good error messages. Assign. All right. So now, oops, something just broke. Okay. We get now yet implemented assign. So now we just have to go fill these out, which should literally just be like copying from these. Wow, where am I doing that? Instruction.asm. Here we go. Instruction to asm. Add. We're starting with assign though. Assign. Oh yes. Yoink. Okay, so there's a lot of bad stuff in here. Whoa. Oh, this is doing. Oh dear. Hold your horses. Okay, okay, and then here we'll do like that. So then this whole entity to asm thing is all we're missing. Maybe. Also, how are you handling global constants again? Oh no, you brought that up again. I was tactfully ignoring them. But now that you mentioned that. So what's like the good place to in the data section, right? That's where we're supposed to stick them, is in the data section. So that's almost like a I wonder if those should be like weeded out, like separated in the like the type checking / name resolution step. Yeah, you gotta store main and add somewhere. Correct. So what exactly is wrong with treating them just like all the other variables? Because that's what we have been doing, right? It's just like we just pop it on the stack, just like anything else. While you answer that, I will run to the restroom. I'll be right back. Get ready for a jump scare when I get back. I'm back. I try to do it in a not scary way. Variables are local, not global. Message retracted. Oops, I meant to say. I'm hopefully prepared for this. Okay. Yeah, I decided to be merciful and not scare you guys. So what was the reason we can't just store them like we store anything else? They're local, not global. But does that change? Does that change anything? Stack frames are local to one function. Oh yeah, I forgot about the whole stack frame thing. Was that? That was in the Discord, right? Yeah. Okay. So that would be something that would have to trickle all the way down, because we need to make that distinction before the IR, probably in the checker, right? So that by the time we get to this point, we're set up for success. Interesting. Okay, so maybe we should start worrying about that. So those are all some nice to-dos. We don't need this for now. Okay. We are starting to worry about everything. This is what happens. I mean, there's not really a way to not worry about that, right? Correct? Yeah. Okay, so those would go up in the data section. Very interesting. Okay, so where do we... Oops. By the way, we're not testing Codegen, right? Test. Testing Lexer, parser, checker, IR. Oh yeah, not Codegen though. Okay, cool. Okay, so we need. Yeah. Okay, so this is a good thing to worry about. One of those good things to worry about. So yeah, if we have something like this, or even simpler, what if I just have something like, okay, what if I just return with 7? But then up here I have, yeah, what if I just had something like x is, 9, and then I will return with x down here. All right, so here's our example. We have, well, main is also global, but here's like a constant integer, right? So, okay. How to do this? Like, where are we gonna spot this? Like, where are we using that is const? In the, wait, what? Just right here. Where is right here? In the parser. Okay. So let's just get parsed normally, which is fine. They should get parsed normally. So maybe it's by the time we get to the checker. Before you could use registers because those are global, but that was a bad strategy. Yes, correct. All right, so let us yeah, so it probably needs to be in the checker, right? The checker needs to take care of this stuff. What is the checker output? Wasn't I like not happy with the API of this checker? What is the API of this checker? Oh, I think I fixed the API of the checker. That's what happened. Okay, so I'm happy with that now. You could try translating entire programs by hand and then replicating that, maybe? Oh, dearie me. I could do that. That honestly wouldn't be super, super bad. But first, I just want to, like, how do we want to represent this when it comes out of the checker? Like, what does come out of the checker? A checked program, right? Where is this checked program? Yes. Well, okay. All right. So let's do this one then. All right, there's our IR want.asm. Right, so coming from this IR, we'd want like a global start, then we had like a start, and then your new vim config looks sick. Can I have your dot files? Yeah, they're on GitHub. I can send the link. Where are my dot files? Okay. So then what do we want here? We need. How are we doing this before, right? So. There's not. Oh yeah, section tests. Whoops. And then there's also a section. Oops. Right? Or is that what it is? Rodata? What's like the... Yeah, like that. Shoink. Which one do I want for these things? Row data or data? What's the difference between row data and data? Read only. So these are for global constants, right? So this is only read only. So yeah. So we'll do row data. Gotcha. Okay, so then hello, Nadir. I sound like hello, my dear. I'm not sure how to pronounce your name. Nadir? Nadir. But all right, so what do we want to do? Because we treat start like it's a function, don't we? Like everything's gonna get a stack frame, so then I need to use that. Our new trick, which is over here. But we need to know. Wait, I might have just thought of something. Is everything... I think everything that's under this entry section, this entry block, is a top level constant, right? Isn't that correct? Because then couldn't we just do it that way? Or is that dumb? If it's defined under entry and not under one of these like sub things, then it means it's a top level constant because we don't allow anything else to be defined in entry except for top level constants. So can't we just take everything that's in entry and stick it up in the row data? And that's a lot easier than like doing some funny dance with a checker. Yeah, I feel like that makes sense. Or data or BSS. What would we stick in data or BSS? Because data is for read and write, but none of this would be write. Okay, wait. So can I... where were we? Here. BSS. But know that you also have mutable globals. Do we have mutable globals? We don't have mutable globals, do we? I thought we didn't allow mutable globals. BSS is 0 initialized data that saves file size. Okay. So then in here, it'd be like, I have colon equals. Yeah, but do I allow colon equals on the top level? I forget. Is const. Yeah, variable decal only if it's not mutable. And do we only allow? Yeah, we don't allow global mutables. We only allow colon equals if we're inside a function. That's what I thought. Okay. So then, how do we do this? Block label as string. So maybe some sort of flag that's like, this is I'm gonna say this. Let asm equals string new. You know what would be nicer here is if I did this. That way I'll actually get stuff out of here, not just to-dos. Yeah, sweet. I would use an entirely different function for global stuff. Yeah. Okay, so I'd almost want to do. Yeah, okay, here we go. So I'm gonna say if block.label as stir is entry, this is gonna be like a totally different case from the other case, right? So then if it's not, then we say okay, and then otherwise we'll do, oh yeah, and then this. Otherwise we'll do this. And that will be Okay, yeah. This is instruction to ASM. Let's do entry instruction to ASM, maybe. We could literally just copy that. For now. And do this. Ta-da. All right, let me get. Gonna sit down again. Okay. Yoink. But then I need to like insert these at the top, right? How do I do that? Oh dear, my head's cut off. Because I don't want these to be like in the block. They need to be inserted at the top in the row data section. Yeah, okay, so and then yeah, should I store the sections up here then probably? That probably makes more sense. Okay, so let me. That does make sense, right? Okay, so sections. All right, that's probably not good. Let's do text section. What is a section? I guess it's a string. And row data section. I'm hoping you're using the stack for storing local variables, not temporaries. What do you mean not temporaries? Oh, like temporary values? Like storing those in registers or something? So yeah, IR temporaries. Should I store those in registers if I can? What would be the advantage of doing BSS over row data? So I need a register allocator. So you're saying for temporary values I should use registers. Um, okay, so do I want BSS here? Or do I want rodata? Oh, okay. Just for zero constant. Yeah. Oh, okay, I gotcha. What BSS is. That's interesting. I did not know that. Yeah, so then rodata. Okay, so store temporary values from the IR in registers, which means I need a register allocator. Okay, that's fine. We can do that. Unless we wanted to save that for an optimization step. What was I doing down here? Oh yeah, so I have these. Okay, so I'm going to say dot text section plus equals that. And then I'm going to say format. Wait, what? So make my own register allocator, basically. How would I depend on Codegen for that? Format. So I have like global start section text. And then I'd have that, and then I'd have, oh, first I'd have section row data. And then I'd have section text like that. And there'd be because then you don't have to rewrite it between targets. Okay, so make like a generic allocator that you pass in the registers that you want it to use, and then let it juggle like those, whatever they are, so that you can just pass in different registers for different targets. Is that kind of what you're saying? Check out the compiler you sent. Oh, check it out. Red Jallock. It takes the available registers. This is kind of what you meant here? Yeah, that makes sense. Awesome. Yeah, I'll do that. That's awesome. That actually sounds like a fun challenge too. Figuring out how to do that. But then what do you do if you run out of registers? Then you start using the stack? Spill to the stack. Okay. Okay. Hello, Amika Mai. Welcome. If I pronounced your name right. I probably didn't, but okay. What's going on here? Self is already. Okay, this should work. Someone pronounced your name correctly for the first time? No way. Emika? Do they usually say Emika or Amika or something? Okay. I just know that Americans are pretty weird with our pronunciation of I's, and most other places say E. So this you made a compiler in Python, but don't know what language features you need to add to self-host. Only goes to LVM. That sounds super cool. I'd love to see it. Is it open source? Okay, so there's that, and then there's that. Wait, so why did I do this? Oh yeah, so that I could then down over here. This actually doesn't return a string. Or it probably does. Wait. Oh, this is getting messy. Okay. Instead of that, okay. Basic block to as oops. That was silly. Self dot sorry. Yeah. This should be a block. This is okay. I'm changing this API. I don't know. Basic block Codegen. And then we'll have basic instruction Codegen. So then here I'll have just do that. Make this not return a string, but rather we can just do this. Because then here, okay, wait. Isn't that just pushster? That's a good point. This is just pushster, isn't it? Yes, Amika, the language is called Lovely. Oh yeah, good point. Push, and then you can push a char. Very nice, and then okay, so then there's that. All right, basic. Why is this called basic instruction? It should just be called instruction. Okay. This. Oh yeah. So that's what I was gonna do. So QQ. If you needed help figuring out what something cogens to, use Godbolt. What is Godbolt? Compiler Explorer? Whoa. That's pretty awesome. This is amazing. Thank you so much, IC. This is fantastic. That is so cool. If I do mangle this, how do I get it to go again? All right, anyway, wait, didn't I rename this? Okay, so do that, and then this is gonna turn to, okay, wait, this is to do. There's some problems here. But until then, this would become, because I don't want to return a string. Oh, I just totally messed up that macro. Whoops. Okay. How much do y'all use unions in dev, like Rust enums? I use Rust enums all the time, and Swift enums, and tagged unions, yes. Yeah, I use all those a lot. Some types. Okay, there's that, and then can I take this for this? And then do that, and then this just changed from a text section to that. Okay, so then okay, we're getting places. Oh dear, we're getting places. All right, so then up here, I believe there was a problem, right? I forget what it was though. There was a problem. Oh yeah. So then, okay, because not all instructions in the, if it's a entry, need to go in the rodata. First of all, this should be rodata. You know what I'm saying? Because there's like a go-to main. That should be. Okay. So how to do this? Because it depends on the kind of. Match on the inster maybe. All except the last one. That's true. Is it just the last one? Will it always have this format, like definition, and then go to? Okay, so I'll do that. If let, what is it? If it's a go to, then we need to stick it in the normal text section. Yeah, and it should always be go to main. Okay, cool. So what happens now if we, uh-oh. What? Oh. Oh, why are you doing that? Check it out. This is perfect. Yeah, this is perfect. I think. Yeah, if it had a little new line here, this is exactly what we want. Sweet. Let me just find. Now that'll be indented. That's a little bit better. Yeah, this is the skeleton. And then I don't know why there's not space there. Doesn't really matter very much, but just one more at the end, I think. Would do that. Yeah, and then there's an extra one here between the text and the row data. Wrong spot. There, now it looks right. Awesome, so that's a good skeleton. What was that? What was what? What happened? So then it's just a matter of figuring out how to do all these. So let me just switch these. Wait. Multi-cursor in Vim? Oh yeah, you better believe it. Now there should be to-dos, which is more honest. Okay, sweet. Now we got a perfect skeleton. It's just a matter of getting rid of all these to-dos. This is fun now. Okay. It's like whack-a-mole. Whack-a-mole. Okay, whack-a-mole. Starting with, okay, we start with these ones. It's probably easier to start with these ones, right? Like a go-to in the text section is really easy. Go-to in a text section. Instruction code and go-to right here. What does it look like in our down here, right? Go-to. If it's a go-to, then we just jump to the label. That's like as easy as it gets, right? So go-to has a label, which is a string. We just push stir jump label. That's pretty basic. Check it out. Jump to fun 0. And then exit. What does exit do? Oh yeah. Entity. So exit has an entity. Because you exit with an exit code, believe it or not. And then yeah. Okay. So you like okay. So move rex 60. So this is like a okay. We don't need to document it. And then the exit code. Okay. Alright, this whole entity to ASM thing, where do I find it? Right here. I'm pretty sure I can just copy this whole thing and just steal it verbatim. Oh, no, I cannot. It's complicated. All right. Okay, so where were we then? Up here. Pass along the entity. Oh. And then syscall. That's all there is to it, right? Yep, syscall. Very nice. We're going to get to do variable. This guy right here. Yeah, where in the world do these things come from? Oh geez, this was complicated. Hello, Yoan? Not sure how to pronounce that. Lots of names to pronounce. I'm learning. Okay, so this is where it gets complicated, I guess. Because what do we stick? There. Wait, what? Oh. Those need new lines. Yeah, how do we get this is the question. Thanks, William and Jappy, for the explanations. Much appreciated. so we need that. We just need a way. Okay. So let's start. Because I can't get that. Because I don't know where this variable is stored yet. It's going to be in the stack. So I need to make some sort of stack system first before we can do that. Actually, no, this variable is a global variable. So I need to do that first. Right, what's our code? Yeah, it's a global variable. So that thing's going to be stored in the... So let's deal with... Oops. Okay, so we're just missing a line here. What happened to my new lines? I made pretty new lines and they disappeared. There we go. All right, we're missing a line here. That's okay. I guess we could. Well, yeah, okay. Whatever. So that, and then we are going to. So we need to take. Let's do these assigns. Global assigns. How in the world do you do global assigns? I don't even remember what the syntax looks like in assembly. Is that like the DB? Would it be like DB in the rodata section in x64? How do you make a constant and call it x, for example? Is this right? Okay, this is pretty straightforward. We're doing 64-bit, which is 8 bytes, right? So we need DQ, Dairy Queen. Is that what we need to do? All right, Dairy Queen. Yeah, that should be pretty straightforward. So this is not an instruction code gen, but this would be an entry instruction code gen. This is probably the best name. Let's call this like row data instruction. And really all of these except for assign should be errors. Or does it expect? You can mess, yeah, okay. Are allowed in top scope. Really, there should be unreachable. Okay, so then instead of that, we'll say what's in here? Destination and source. Okay, so we'll match on the dest and the source. Excuse me. And then Oh, expect is similar to unwrap. Oh yeah, yeah, yeah. Thank you. That's what I was thinking of. Source. So the destination. What is an entity? There's a value and a type. Uh, okay, DNS. This will be an unreachable. I guess I don't know for sure if these are unreachable, so we'll say panic. Only. Well, they should be reachable. If they're not, they should be. Only. Okay. If d dot value now you just get the name out of here. That's cool. Hello, fake name. And then in here, I will want. What will I want? Yeah, like self poster, something like that. And then this would be okay. Name DB, right? And then Coolio. What is that gonna do? Okay, perfect. It's this. This is easy enough. Num. And then we can literally just do that. Shoink. Function pointer. Oh. That's interesting. What did we do in the past? That. Okay. So then what in the world is this to do assign? Oh. Cool. Function pointer NASM is just a label. Also, labels are supposed to have a colon after. My labels do have colons after. These guys? These are colons, right? Yes, this is just a label. Oh, is that all there is to it? I gotta stick this guy in there? Like, would this be correct if fun number 0 was right here? Colon after the variable names? Oh, here? Oh, those should have. Okay, yeah, I can do that. I can do that. How is that? Ta-da! Oh yeah, I need DQ. Dairy Queen. Thank you, people. Catching all my errors. Yeah. Okay, so Dairy Queen 9, that's cool. And then, so would this be correct if this said fun 0? And is it a DQ? Like, what is a label exactly? Like, how does one store a label? What would I do to make this correct, I guess is what I'm asking. This is very interesting. Yeah, I don't really know. I don't know assembly well enough to do this. I can ask the AI overlords. If I want to store a label for an ASM section in x64 NASM in the rodata section, how would I do that? What? I want to store the label. Oh, did I write x63? Whoops. It got my drift. I want to store the label to a function down in the text section in the rodata section. Get it? Oh. Like that. And you should use a Dairy Queen? Like, why a Dairy Queen? How big is a label? I don't understand. Function pointer. Yeah, that's what it did here. Function pointer. Coolio. Yeah. Dairy Queen. Why exactly is it DQ? What's the size of a label? Yeah. Why DQ? Oh, because it's a pointer. Oh. Oh, I get it. Yeah, pointers. Cool. So that's kind of what I had. Except for these people are not using, these people meaning this guy. He's most definitely not using a colon right there. NASM accepts missing colon sometimes, but there is a warning option for that. Okay. Gotcha. So I should use them. So I basically need to figure out a way to get this name right here. Shoink. Okay. Let's figure that out. Do I have access to that name? I guess I should maybe the source. Where the value. Okay, I guess it depends on the type, right? The type is what is the type? Oh, type. If it's an int, then do it that way. And then another one here. Yeah, perfect. Oops. Okay, so these are the same. So otherwise if it's a function, right? Function pointer. Ooh, sweet. Very nice. This guy is no longer needed, I guess. Just snag it out of there. And then just do one of those. How's that? Ooh, look at that. That is so cool. You have no idea what I'm doing now? Wait, what do you mean you have no idea what I'm doing? This thing? You have a function entity to ASM so that you don't have to do this. Hmm. Smart kid. Okay. Yes, that is exactly correct. I have a function that does exactly this. So, what does that mean I'm gonna do? That means I don't actually need this. Wait. Yeah. You just do this every time. Oh yeah. Oh yeah. It's right here. Oh yeah. Okay. Thank you very much. Ta-da. Uh-oh. Ta-da. That was much simpler. Thank you. So what's missing now? This line right here, right? And then it'll work. How do we get that name is the question. Do I have that name? Variable? Oh, it's right here. So can I just do the name? In this case I can. But once it's on the stack, I won't be able to get away with that. It's not actually what I needed. Very nice. So that pretty much is perfect, isn't it? Yeah, that only works for global variables, because for local variables, we'll have to pull them off the stack and then do stuff with them and then push them back on the stack and stuff. But for the time being, this works just fine. We could even try to run it if we wanted to. You might have to find some way to differentiate those or do something with the find. I think they should already be differentiated because there's these two. This is the row data instruction Codegen. So this takes all the instructions up in the row data, which is only assigns. And then these ones are different. Oh, unless you meant down here. Because there might not be a way down here. Good point. Very good point. All right, let's try to run that. Just to ensure that our ASM is on point. Okay. This is what was my last commit? What do we call this? Started redoing Codegen. Support for global variables, or I guess partial support, or global constants, really. Okay. Shoink, it's on GitHub, if anybody wants to see it. And then this guy, no, not this guy, this guy. Let's try it out. Okay. Oh. What? Oh. Okay, so now there's nothing. Okay, so then let me get a what is it? Lovely. Hey, somebody just starred. How do I do this code? I think we have to use. I can't even copy, but it's basically just the URL plus a .git. Yes, get reset dash -r would have been the correct way to do this. Oh, it is. Cool, it is. CD, or is examples? Well, I think I can do this. Cargo run dash. What was it? Dash compile. Oh yeah, okay. Oh, we already have the ASM. Never mind, because I think I got that. Yeah, it's all right there. Okay, cool. So then I can just do what? NASM. And then what is it? LD. And then wow, that's not really what we expected, is it? Well, here's the thumbnail anyway. But you need to dereference the label. Oh, here? Is that only for constants though? Hey, that worked. Yeah, that makes total sense. But the thing is that, oh yeah, no, that just totally makes sense. Okay, period. Coolio. Here's the new thumbnail. Or I guess I should include more of that, so it doesn't get okay. All right, awesome. I think I might stop there. Seems like it. How do you just shut down now? And get rid of that. Cool, yeah. That seems like a good stopping point. We'll, yeah. They're gonna do another one of these tomorrow, almost certainly, and we'll pick back up where we left off. Probably starting with fixing that issue with these square brackets that we need. But until then, see you guys online, and thanks so much for all the help.